So hello everybody and welcome to today's OpenONU Go call. Thanks for joining. As usual, the call is public and recorded, so please be mindful of whatever you share within the team and the comments you make. Having said that, as usual, we can start with the current status of the implementation. So first of all, if Michael and Holger could give us an update on the OMCI flow pushed patch, that would be great.
Michael, are you?
Yeah. We were busy in preparing that patch the last days, and today I made a further patch download to the patch version 3, which includes a further correction, which I still found for the tag profile processing. So yeah, anyway, I think that might be a state that should be okay from my point of view. The previous comments from Andrea were incorporated, and if needed, some new stories were created in the recording storybook for the open adapter. And yeah, so we have to see if some further comments come in on that patch, and then we have to consider to merge that version. Yeah, perhaps some more comments on the functionality. So far, this is implemented and tested based on the on our normal robot test case that we use for testing, where we receive a quite maybe simple flow configuration, perhaps some kind of default flow configuration. As already mentioned in some of the other open adapter stories, I think this is not some configuration that is related to one of the customer scenarios, meaning I think it is no real DTAG scenario or AT&T or Turk Telecom scenario. So we created new stories to follow up the configuration specific for these customer scenarios, because they might be a bit more complicated, and we have to check then if some code adaptations have to be done for that, which I think will be necessary. But yeah, for the moment, at least we have a basic configuration possible to get the flow pushed state reached for the, let's say, default flow configuration.
I think that's great. The only suggestion for myself would be to start with the simplest one of the three, which is the Deutsche Telekom workflow. Because at that point we can start maybe looking at having a scale test for that. So just as a personal question, how do you generate the flows that go to the adapter?
So we do not really generate flows in kind of active action. When we use the Volta configuration per default, some flow configuration comes in. I don't know where from and how it is generated. So at least there is.
Actually, the data comes from the API call, right? So the update flow incremental.
Yeah, of course, there's a RV core interface invocation that delivers the according data, but I don't know where the data is really coming from and how is this is configured.
So from my understanding, those will be the EPOL flows from the AT&T workflow.
Mm-hmm.
Would my guess be correct? Because those are the only ones that automatically get pushed to a port when it comes up. It's going to be one flow, EPOL flow.
Yeah, in the end, it's a simple stacking scenario, and in my point of view, at least what what we analyze to get out of the configuration also in the Python adapter. So there is a simple stacking scenario from some untagged or priority tagged scenario to some specific UNI VLAN. Yeah, I don't know if that corresponds to some AT&T scenario.
Sorry, I maybe missed you there. What can you repeat?
So the configuration that is applied at the moment in this as a kind of default configuration is a simple VLAN stacking scenario. So coming from the ONU, the frames would be expected either as untagged or as priority tagged. And then they will be stacked on the ONU with the corresponding UNI specific VLAN tag. So that's why I say it's a simple stacking scenario.
Okay. Yeah, makes sense. Maybe what I would ask is a couple of things. One is just maybe go into ONUS whenever you have it up and do flows there, and also device flows list for your ONU in VoltCTL, so we can see exactly what you're sending down. That would be one thing to do. And the next step would be to start Volta with the DTs, with the DT workflow. And at the start, you'll actually see no flows, but then you should provision a subscriber through ONUS, and that you should see 4 flows coming down to the adapter.
Mm-hmm. Okay, so Andrea, perhaps you could send us the commands in a perhaps separate mail or in Slack, because we are not familiar with these ONUS commands. And on the other hand, that was one side of the discussion we had in mind for today, is the question if there are no real regression tests for specific flow configurations, for instance, for the DTAG flow. So maybe there are already some robot test cases existence that incorporate these DTAG flow configurations. So maybe then we can try to reuse them.
I mean, you got to the point where you probably can run the sanity test on it. Might as well try. Because what the sanity test is just brings up the device and tries to push subscriber and make sure that the flows are there, the meters are there for the OLT. So this is what I was suggesting here is manually for your development workflow, but what you also can do is you can do make sanity DT, I think. But you still need to start Volta with the DT workflow capabilities. I can send you the commands for that.
But with this test, no data paths could be checked, right? Or is it sendings? No.
If this passes, we can maybe try on a pod a sanity test with data path. But first of all, we need to make sure this passes. So I'll take an action item to send you a few commands and send you a few links about this.
So I posted in the chat 2 links to the guide that should contain most of the commands.
Thanks, Theo. I wanted to do that, but I was. Yep. There you go. So this one, the first one is like, tells you how you can see things being there in Volta, like for example, subscriber provisioning. This is how you do it. Volt add access, subscriber access in ONUS. You can check it was programmed. You can check that the flows were in ONUS. This is all in ONUS. It's not here. Maybe we should add it. You could do voltctl flows list device ID. Let me take a note of adding that here.
This could also be incorporated into our robot test case, right?
Yes.
Check. Mm-hmm.
But let's say that if the DT workflow actually passes, we might be ready to switch over to maybe a trimmed down version of existing tests.
Mm-hmm.
Yeah, but my assumption is that it won't really work, let's say, in a complete way, because I think, and if you say that 4 flows are set up, I guess per UNI, then I think there's really the need of some incremental flow configuration within the adapter, and that is something that we have not yet provided. So I guess, well, something must be done within the context of the according story that we have created for that. And for the moment, I guess it won't be completely working for the detail.
I mean, my suggestion would be just to try it and see what fails and see how much is missing, and then we can go ahead incrementally on that.
Yeah, of course. Mm-hmm.
Sounds good. Okay. The second link is how you can start kind Volta with the DT workflow. There you go.
Mm-hmm.
It just changes a few things because DT doesn't do EPOL, doesn't do DHCP, and we need a specific SADIS configuration from VBSIM. So it's fairly easy. Should be no problem. We can take it offline if there is any, but I'll add the voltctl flows command there.
Just a heads up that those settings will change very soon, but I'll update the guide when they change, because we had to make some big change in VBSIM to support the Tarak Telecom workflow.
Yep. Thanks, Theo. Okay. So I saw that there was a discussion. There was a discussion from like a week ago on a failed communication to the core error, and you brought up some more details about this, Michael.
Bless you. Yeah, we had a Slack communication, if you refer to that, I guess, where in this, sporadically, but at least it could be reproduced. The error from the ONU adapter perspective is that the transport of the OMSI frames is not possible anymore. So we just receive an error on the inter-adapter communication when sending OMSI frames. Well, the last information I put into Slack for that was that I do not see this error anymore in case that I change the timeout for the RW core component from 10 seconds to 30 seconds. So in that case, in my environment, this error does not appear anymore. And I've also posted a comment from my side that, in my point of view, it shows that the error treatment for such kind of problematic situation where the processing on the ONU adapter perhaps takes longer than the 10 seconds seems to be not complete, and the problem is that in this case, the OLT adapter and the RW core are working closely together for the flow configuration, also in respect to checking the tech profile configuration. And it's very hard to find out where the problem, in my point of view, in these components is really located. I saw that Girish had still some comment and wanted to check my test environment, some parameters for my test environment. So I put that into the Slack channel. Maybe Girish tries to follow that up. I don't know. The errors that we see in the RW core or OLT adapter logs seem to be not really helpful. At least they can give a hint, but yeah, the problem is that this is a processing issue when it comes to process many messages in a multi-ONU test environment. It's a little bit hard to analyze that. For me at the moment, it looks fine because I'm able to increase this timeout and then things are working smoothly. But I think this error treatment that might be implemented in the RW core or OLT adapter might need some improvement.
Hello, is anybody there?
Sorry, I was talking to myself. I was saying that, I was saying that maybe what happens here is that given that the OpenONU Go is faster than the OpenONU Python one in processing things, we're just exposing a race condition in the core or in the adapter, in the OpenOLT adapter. That was not there before, that we didn't know about because the Python version never exercised this as much.
Yeah, the complete timing behavior is totally different for the RW core and the OLT adapter in this test environment.
Okay, I'll maybe take it up with Girish and see what he thinks about this. And I might ask him to reproduce this. Do you have the exact set of commands that you run to do?
Well, it happens as part of our normal robot test case that we use for all the verification.
Well, it would be helpful if you can send the exact list of commands that you run, so I can send them to Girish.
Mm-hmm. Okay.
Or even open a Jira ticket with the set of commands. I can actually assign that to you. And then I'll take it up with Girish to see if he can take a look at the core and stuff like that. Okay. Any other update on this? So I know that the patch needs a manual rebase, this one. For some reason, there's a merge conflict, so I'm okay with it, but just needs a manual rebase on top of whatever the existing master is.
For the moment, I don't know what what to do with that, so what it really means, this manual rebase. But
So git pull minus rebase.
I guess in emergency, we can clarify it offline.
Michael, I think I know what to do. It was this order of git commands where you have this merge in between, and then you can push another patch set which is merged to the head. I think we can do it together.
Yeah, there's actually an ONUS article, if you search for ONUS Garrett workflow, that has some of those steps listed.
Yes, it's this one. I think I sent it out, but
Because I always have to go to it when I get merge conflicts.
oh, Garrett workflow.
Yeah, Garrett workflow. Yeah, sample Garrett workflow.
I'm just gonna put it in the document just for.
Yeah, and that really helps, especially with the setting the branches and all that crazy.
Done. Okay, if you can do that, that would be great. And then as soon as it passes Jenkins verification after the rebase, I think we can go ahead and merge it. So that's really good. I know there is the release thing that I asked you guys to do, and that is dispatch. And that has a Jenkins -1. So I've asked Zach to override the Jenkins. I think he'll do it in the next few hours, and then I'll merge it. Okay?
Okay, this only a formal thing, you know.
Yeah, exactly. It's just a formal point in time. Yes. Okay. So I think that if that is done, I would like to ask Divya to present the document.
Andrea, one thing, I don't know if you can discuss it here or should discuss it here. When checking, analyzing the behavior of the Python ONU adapter,
yeah.
Concerning the reconciling, I encountered that it looks like that the flows are not updated in the reconciling process. It looks to me that after the tag profile reconcilement, this process is stopping and not reconciling the flows. Chip, can you remember this? Or is it too long ago?
This was a discussion from today, right?
Yeah. Because then we are now wondering how to get the flow configuration information after the restart of the ONU adapter. And I don't know if it is missing in the Python adapter, or was there a certain reason to not do this in the reconciling?
That is a good question. I was not really aware of in the Python version why some choice were made. Matteo, maybe you know better than myself, or David, somebody that's been with the project a lot longer, I guess.
What do you mean with the flow reconciliation? I mean, does
OpenONU
adapter cache flows or something?
Like,
no, as
for
I
example,
know,
when the complete ONU adapter is restarted by Kubernetes, then we are receiving the reconcile device request, and we have to set up everything by our own. We have to fake the ONU indication. We have to read the tag profile from the Kiwi store or from the etcd. And afterwards, I would have assumed that then also flows are set up again. But I haven't seen that, for example, that the Python adapter is storing the location of the flows to be reconciled. So, and also in the code, in the logs, when I restart the Python adapter, I don't see the reconcilement of the flows. That's why.
Okay. When you, during reconciliation, when you retrieve the technology profile information from KV, do you apply it to the ONU itself? I think the reconciliation is only rebuilding the memory of the and cache of the ONU adapter. So it shouldn't include anything that we will apply to the ONUs, because we assume that the ONUs are there working, continue to work there. So we shouldn't say do any configuration, new configuration on the ONU itself.
But according to the logs, the Python version is doing that, exactly doing this. It makes a mip reset and a complete mip upload according to the logs. And that, so we also thought we have to do it, because I don't know if we have the exact configuration image of the ONU after the reconciliation currently. So the idea was to do it in the same way as a Python adapter, where a lot of configuration is done after the reconcilement. But your idea is that only the memory of the adapter itself should be restored, and not the ONU should not be invoked, and also the other components, right?
Yeah, that's what I'm thinking. I mean, we shouldn't involve the, because the ONU itself is there and working. So we have to get ONU adapter to the previous states, to its previous states. So,
but okay, what I have done is that I brought up the one ONU with the Python version, and then made a restart of the complete container of the open Python ONU adapter, and then I saw a lot of I saw the complete MIP download, MIP upload cycle starting, and also the download, and then the tech profile provisioning.
we should check this. I mean, I will also review this on Python side. I'm not sure, 100% sure about the code, but in ONU adapter case, we shouldn't start all MIP downloads, uploads, etc. configurations on ONU. Otherwise, if the ONU adapters say that manage 1,000 ONUs, in case ONU adapter restarted, we should reconfigure all 1,000 ONUs. I think this is not the aim thing to do.
I thought part of the reason was when the ONU adapter restarts, there's no way to guarantee that the ONU actually has what we think it has. And so the simple solution was just to essentially reinitialize the ONU. I do have, however, agree with you that if the ONU adapter is monitoring or managing 1,000 ONUs, then having it reboot all 1,000 ONUs is not optimal.
Yeah.
It should be able to it looks like it does do some restoration, but it doesn't do anything with flows. But on a reconcile, it should probably skip the MIB upload and go straight to the check audits. I mean, the normal startup state in the device adapter should know if it's reconciling or not, because it can get the previous MIB data sync value and find out if the ONU is in sync at that time with the previous before time.
But the question is, the data you have available during reconciling is said before. Is it really the configuration which is really at the ONU at this moment? So that's why I can agree with the current idea to set up all the OMSI configuration again. So otherwise you would risk some data inconsistencies between ONU itself and the ONU adapter, right?
Well, I think there are facilities or opportunities to test if the last done configuration is still available in the ONU. So you can make a specific GET request on the ONU for a specific configuration that was sent before the reboot, and to verify if it's still present in the ONU. but we have to say that that is something that is not part of the Python adapter. So we still try to get on some parity functionality with Python adapter. And if that should be a request or some idea to solve the problems in case multiple UNUs are connected in the reconcilement, then this will be a different story.
On that note, I would have to say that we have never tested adapter ONU adapter restart, meaning that, for example, for the OLT adapter, for the RW core, for the OF agent, we have automated tests that do the bring down and bring up of the pod. We have never done it for the OpenONU adapter in Python. So I would not mimic 100% what is in the Python version, because it might not be what we actually want. So my suggestion would be to give maybe a little bit more thought on exactly what we want in this case, and maybe Mahir and everybody can help here, and then implement it. Because it might be that the Python version does not really do what we need.
Yeah, but at the time being, the safest way would be to do a MIP reset and to configure the UNUs again. And the Go adapter is fast enough to do this, I think. But okay, if we find a way without newly provisioning the ONU, that would also be fine.
As I remember, the reconciliation process, is coded by Matt in Python version, and it tested also. Somebody, perhaps from Radisys, I'm not sure, but somebody from Radisys probably did some tests and edits for reconciliation in Python adapter, and it's tested as far as I know. But it may not be a part of the automatic test, but it's tested. As far as I know, in the state machine, OMSI state machine of the ONUs, when they start MIP upload, before MIP upload, they go and check the MDS flag or MDS counter on the ONU and the one in the database. So if they are same, this means that the configuration of the ONU and the one in the ONU adapter are same, so no need to update the ONU itself. For the ONUs that does not have the correct MDS value, their state machine is restarted and this all MIP download and upload things happen. But in case, if you want to make a MIB reset and do everything from scratch, then probably you need to be triggered. The ONU adapter need to be triggered by someone for flow insertion. I don't know how ONU adapter itself can do the flow insertions, because it doesn't have an ability to go and get the flows and from KV store and decompose them according to the ONU ports and routes. So at least RV core and OLT adapter should do something to trigger ONU adapter. This is not a thing that ONU adapter itself can do.
Okay, regarding reconciling the flows, could also be possible to store the information which were received in the update flow routines. This information could be retrieved from etcd at the moment where we need it and configure it again. Or the other possibility would be that the update flow routine is RP function is called even after the reconcile device request. That would also be a possibility. Okay, we have I think we have to think about it. I wrote down these 3 alternatives here in a chat and in Slack, and I think Girish will comment on that.
Yeah, I think the big missing part is storing the flow data, the flows themselves, and their attributes, which gem ports that they touch. I don't think that's in the current adapter.
But
but everything in the MIB database should be true. So if the MIB database that's stored in the KV store is accurate, and you're able to do the flow data, which points to the appropriate MEs instances, then the existing state machine logic should work on a restart.
Okay, you mean you should not rely on the flow data itself, but on the OMSI requests resulting from this configuration?
Well, if the device adapter restarts, then just let's not consider the actual flow from ONUS and all. If the adapter restarts and goes out to the ONU, then the device adapter's MIB database is the source of truth. And from the MIB data sync, it can find out if the ONU device is truly in that state. And if MIB data sync is equal, then there's a high confidence, about a 0.5% chance of error, that the ONU is not accurate. So it might want to schedule an audit. And if the MIB data sync is invalid on the ONU, then the OLT's, the device adapter's MIB database, should be sent down to the ONU as the authoritative database. Okay, that's not considering anything that, of course, we store with the ONUS flow information. So that's just the simple traditional OLT reconciling a ONU device, and that's in the current data. So what's probably missing is that, okay, you do a reconcile and you come up and you do resync that database. What happens, you have to be able to handle a incremental flow remove request coming down, so that's where saving the flow information to the KV store is one of the missing pieces.
But it looks like that the current implementation in the Python adapter is that the whole process is done again, and also tech profile handling and so on, and not only the stored OMSI requests are sent, but the complete mechanism is running to get for example, to get the stored tech profiles from the etcd and to form the corresponding OMSI requests, and not taking the ones from the OMSI storage.
Yeah, well, I mean that could be true, because the tech profiles and the flow information is completely independent of the MIB state machine.
Yes.
Yeah, that's what the missing piece. So, I didn't work on the 2.0 when the device adapter reconcile came into being, but so that piece may be missing. But to do a disruptive, just because the device adapter does a restart, to do a disruptive, disrupting the ONU's communications is probably not preferable. It's something we could probably live with initially, but eventually you should be able to reconcile an ONU without having to disrupt the data path.
Okay. Mm-hmm.
So, there's one thing of getting it working and getting the scale up, and the other one is making it perfect. So,
I see.
And I think everybody would prefer to getting scale first, as opposed to the perfect non-data impact.
Okay.
Keep in mind that ONU adapter does not know any mapping of the technology profile to ONU adapter, so it doesn't know which service is used by ONU and which is not. So it can, to me, ONU adapter itself cannot read technology profiles from a database and apply them to any ONU because it doesn't have this mapping, as I know.
Actually, this is done because the tech profile download request in a normal startup.
It comes from OLT adapter, the tech profile downloads message. So OLT adapter triggers this, and upon that, RV Corp triggers it. I mean, if you start the MIP reset and you start to initialize the ONU adapter, ONU itself, then probably some ports and ONU device statuses are notified to ONOS, and it triggers the flow remove process and flow addition process, etc. So I think this should be in this way, because how can you have ONU adapter know that which subscriber gets which service? So which tech profile should be configured on the ONU? Does it have this information?
Actually, we don't inform AviCore or OLT about our actions. That is also not done in the Python adapter, so that should be not visible to ONUs that we are reconfiguring the ONU. It was also taken from the Python adapter that any status update or reason update is suppressed towards the system.
Okay, seems something missing interesting here, so we have to investigate together.
Yeah, I think so. Thank you.
Okay, yeah, let's progress the discussion. I created a document, so if anybody wants to put any thought in there, just go ahead. I'll keep the point open for next week and for next meeting, and if anybody has any thoughts or discussion, we can have them there after the investigation that we can do. Okay. So next up, I just want to give the floor to Divya to present what she did with the MIB templating.
Yeah, okay. Andrea, can I share my screen?
Yes, please go ahead.
Okay, thank you. So you're able to see my screen?
Yes.
Okay, thank you. So hi everyone. We have implemented this feature called creating and persisting a MIP data template. This particular document describes the automated approach of creating a ONU MIP template from the scratch when the first time ONU device is enabled, and we'll store that template into etcd. So that template can be used for following ONUs with the same hardware make, model, and software version. So to acquire the MIP data for the ONU, when we do the enable device with the VOLTA, the OpenONU adapter will learn about this MIP data via MIP upload procedure. Once this MIP data has been learned from the ONU side, there are many state transactions happen, such as discovery, MIPS incomplete, and all. These states are very transient and immediately moves further in the OpenONU state machine. So if the ONU has completed MIB in sync procedure completely, then you can see the below logs. You can see the logs in the OpenONU adapter code. This is some snippet I have put here. I'll show you after when I show the demo. And this code snippet shows the method for creating a MIP template and storing it in a etcd once the operator enables the ONU device. And this method is being invoked if there is no template is available in etcd. So this particular method does the following job. It creates a JSON file for the MIP data. MIP data, and this JSON file contains the unique template name, template create date, placeholder for a serial number with the class ID 6 and 256, placeholder for a MAC address with class ID 134 with other related data, MIP data. So for creating a unique template name, the template name in the form or in this format comes with the vendor ID, equipment ID, software version, and this will concat with the service role, the OMCI. I'll show you the path afterwards. So this is the template name we create, and we are extracting the vendor ID from the class ID 256. Extracting the equipment ID from class 257. This all data is coming in the MIP data. Extracting software version from the class ID 7 and creating a unique template name, and adding template create date that will be a current date, and then creating a placeholder for the serial number with the for the class ID 6 and 256 like this, and MAC creating a placeholder for MAC address with the class ID 134. So once this all the procedure done, we are creating a JSON of this and storing that JSON to this particular path in the etcd. To read this template, once it is generated, you can use this command to get the data. So just I'll show you. Logs here, OpenONU. Then so there are no devices right now. And we'll just check whether the template is there or not. So there are no templates in the etcd. We'll just create a device. We'll just enable the device. Once we enable the device, so it is enabled. You can see so many logs are going through. So to check that, just will grep that log which I shown. So you can see once the MIP upload is complete, you can see this log and the OpenONU Go adapter logs. And once it is uploaded, you can see. this log says that the MIP template is stored into etcd. We'll just get a template from etcd. You can use this command. You can see the template is in the etcd, and you can see the serial number placeholder has been created for the class ID 6. So I'll show you in a proper format. So you can see this for a class ID 6, this placeholder has been created. In this particular MIP data, we haven't got class ID 256 and 134 to show you that MAC address and for a placeholder for a MAC address. So yeah, that's it from my side. Any questions?
Yeah, Divya, thank you for the demo. Question, do you plan to set up a robot test to test whether this template can be read from the second ONU which comes up? Or should we plan this?
The scope of this particular JIRA was this much, so we have worked till this only. So there is no plan for that right now.
Okay, but what do you think? I think it makes sense to have at least a test case in our verification robot test suite where we have a look whether the bring up of the second ONU is going much faster due to the skipped MIP upload cycle, right? It would make sense to have such a check.
I think
Yeah.
I think it does. It does make sense. If you don't mind, just open a JIRA for it, and we can find somebody.
Yeah, I think probably we can care about it. We will think about it. Okay.
Yeah, for sure. But I would still track it with the JIRA. And thanks for that was amazing. It was still very good work. I don't think this is actually going to be used in production, but for testing and speeding up and creation of the templates, this is perfect. It's great.
That's very good. Thank you very much. Yeah. One question left. Andrea, I think you wanted to have a file as a physical file version, right? Should this be automated, or is it okay to have it as a manual intervention to create this file with a MIP template?
What you mean, getting the file out of the system?
Yeah, I think you wanted to have this to give it to the operator to have a physical file with a MIP template, or isn't this valid anymore? This
I mean, we could create a script that fetches it from etcd and saves it somewhere, but it's such a trivial thing that not really important. The functionality is there, and it's great, and it's good enough, I guess, to have it for now. And if we have to create a script, we'll create a script. But for now, it's fine having it like this.
Okay. Yeah. Thanks.
Thanks.
Is that coded into ONU adapter Go?
Yes.
Yes.
Does it check if
this code is merged with the master of ONU adapter Go? It's there.
Does it check if the template exists in the KV store or not?
Yes,
or
yes.
It overwrites it?
No. It checks first whether the template is available in the KV store for that particular vendor and all. If it is not there, then only it will create.
Okay. In case you restart this ONU, then the ONU will be.
No. That time the template will be used by the ONU. This template will be used by the ONU.
Okay.
Yeah, etcd should be up, but etcd should not. That data should be there.
Okay, perfect. Thank you.
Okay. Thanks a lot, Divya. That was a great presentation, and thanks for sharing it with us, and thanks for the work. So I think
only one last question. could we come into a race condition if several ONUs comes up simultaneously and tries to write into the etcd, or is this blocked by a semaphore or something like this? Because currently we are starting up the ONU simultaneously, and probably when the template is not present in the etcd, every ONU which comes up will try to write the file. I don't know if this could be a problem.
We haven't tested in that scenario. Even I'm not sure.
Oh, okay, we can discuss offline.
Yeah, maybe we can take it offline. It's a valid concern. It is a valid concern. Let's just maybe take it offline. Yeah. Okay. Okay. Thanks everybody for joining. Let's continue working on the patches for the flows. So with the commands and things like that. And in the meantime, let's continue the investigation of the reconciliation. And let's discuss on Slack, on the email, and let's come together again whenever is needed, either next week or the week after. Thanks, everybody. Take care. Bye-bye.
Okay, thank you.
Thank you.
Bye.
Bye-bye.
Bye.
Thank you. Bye.